Thanks. Thanks, Will. That sounds great, and thank you all for attending. And I do like to start with you know, I I obviously am quite proud of what we put together with TensorFlow, but it's also can be um, a pain in the backside to work with sometimes. So thank you for your patience. And yeah, so maybe I can start off with talking a little bit about how it came about. Um, because back in 2014, I had a small startup that was doing deep learning on phones, and had an open source framework for doing that at very sort of early, not very sort of not many features, but um, Google were interested in the technology, so they acquired us, even though nobody really knew what deep learning was going to be used for on phones. I remember having a conversation with with my first boss at Google, and he was like, "Well, this is neat stuff, Pete, but kind of scratching his head a bit and saying, we're not really sure what the application's going to be." But luckily, I actually, in the first few months I was at Google, I ran across the what was the beginnings of the TensorFlow team, back when it was just a few people. And I thought what they were doing was really neat. It was a bit of a crazy idea itself, because nobody at Google, apart from Jeff Dean, really understood why we would be open sourcing the code that we were going to be using to run all of our machine learning at Google. And it was only because Jeff Dean actually had a lot of, had a really good reputation and enough power that he was actually able to kind of push through this idea. And it also there was a lot of pushback because there was, an existing framework into, an internal framework at Google that was a bit of a pain to work with, but a lot of people were used to it and kind of wanted to stick with that. So just trying to get the whole of the company to move over to this new, somewhat buggy, version 0.2 sort of framework was, was tough too. But it was kind of amazing when we released the first version. It honestly, I think, took everybody by surprise that there was this appetite out there in the world to use this sort of stuff. And like, it was great being one of the first kind of, system frameworks to come out there, something that was aimed at deployment, not just research. But it also meant that there were a lot of things that, we didn't understand. We really put out what was a mathematical numerical library. And it turns out that that's not a great interface for a lot of people. Like, it's really helpful to have that numerical processing power under the hood, but you really want to have some kind of interface over the top. And it wasn't until we really focused on Keras that we, were able to make it a bit more user-friendly. And, there's, it was always interesting seeing, I'm a big fan of PyTorch. And PyTorch has always been a lot more focused on ease of use and, really trying to work on the research side, versus, so it's much easier to kind of create new models, whereas TensorFlow in a lot of ways was more constrained because we were always trying to do both creating new models for research, but also making it possible to deploy them at kind of Google scale. So that meant that we ended up, in a lot of cases, having many, many confusing options because we needed that flexibility to be able to sort of, deploy these across thousands of machines in a data center. So just to give you some sort of, flavor for some of the design decisions behind, behind TensorFlow. I mean, it does mean it's not an ideal kind of learning environment in a lot of ways, because you're immediately exposed to all of these different parameters and switches and decisions you have to make kind of before you really know what's happening there. Oh, and by the way, feel free to jump in with questions, and if there are things you want to hear more about. But the specific stuff I was focused on was, I'd come in with this background in doing deep learning on phones. And so because I was one of the few people at Google who'd been doing deep learning on anything outside of the cloud, really, I became the person responsible, initially just the one person who was doing sort of Android support for TensorFlow before we launched. And we managed to launch our first public version with Android support already built in. Like, that was very important to Jeff. He was really convinced that, even though we didn't have good use cases yet, that there would be, it was really important to have this kind of support on device as well. And it turned out he was right. We over the next few years, we ended up shipping, I think on last time we checked, it was about 4 billion phones. And every major Google app ships with TensorFlow Lite. A lot of other apps outside of Google are using it as well. The use cases turned out to be, many more use cases than I would have imagined. Everything from the obvious, sort of sorting photos, doing the kind of, image classification, to actually doing photo effects, all sorts of things in the camera, from blowing out backgrounds in the camera, to doing that on sort of things like Meet, to doing voice recognition, which I will, come back to in a second as well, to detecting, actually, one of my favorite applications is detecting taps on the back of your Pixel phone using the accelerometer, so that you actually are able to use the back of your phone as kind of an input surface, which, I would never have, thought of that particular use case, to things like the keyboard, doing, keyboard autocomplete, doing things like smart reply for messages and emails, and even things that I would never have expected, like battery management. It was really nice to kind of see how that grew. And one of the transitions we had as well was going from the initial release of TensorFlow on Android was literally the whole of TensorFlow just ported over to run on Android and then iOS. And that was really convenient because it was exactly the same code that we were running in the cloud. But it meant that, for one thing, the code itself took up 20 megabytes, just executable code. And that's really a lot of space to take up on any application. That means everybody has to download that extra 20 megabytes, especially on app stores. There are often kind of, limits at around, or there were around 100 megabytes for, the size of the app, and things got less convenient. And it also meant it was really hard to optimize because people had to kind of figure out how to optimize stuff for the phones in the same code base that there was all this support for all of these cloud TPUs and GPUs and x86 CPUs. And so that's where TensorFlow Lite came from, was this idea of, hey, let's actually have a separate inference engine that's focused on just running on phones. And so that was kind of like version 2 of the mobile, the phone support for TensorFlow. And that has been, it's definitely been very successful in terms of getting things out there, but it has meant that it's introduced this problem of translation, because you're going from one representation when you're training to a completely different representation of the model when you have to run it in TensorFlow Lite. And TensorFlow itself has, last time I checked, it was over 2,000 different operations that it supported. And TensorFlow Lite supports, I think, about 250. So there's this kind of mismatch when you have to do the exporting. And this has really been a persistent and growing problem, I think, everywhere across the ML software ecosystem. Is you're sort of entering this situation where you almost have this kind of MATLAB world where you have these really easy to use prototyping tools on the research and the model creation side. And if you want to run them at large scale, you actually have a whole bunch of challenges around getting from that training environment to the kind of deployment environment. And this is, you'll have encountered this when you're going from TensorFlow to TensorFlow Lite in the kind of examples that you've been using. But this also comes up for things like, oh, I need to run this on a TPU in the cloud. Well, it turns out cloud TPUs only support a few hundred operations as well. So you have to actually think about how to build your models in a way that's friendly for the deployment environment, even if you're just running purely on the cloud. And you run into this as well with things like PyTorch, where you need to convert to Onyx, for a bunch of, deployment cases. And you'll run into, very similar issues. But the main thing I want you to take away from that point is, if you're struggling with the export step, you're not alone. That's actually probably the most painful part of the whole process for every practitioner I know. And you might think that, things like MLIR or other kind of intermediate representations might help, things like Onyx, like I mentioned, but actually in a lot of ways they cause more problems, because you're adding yet another translation step. And fundamentally, this whole kind of ecosystem is very poorly integrated between each separate technology. And if you're getting frustrated, that's very normal. And you really should plan, unfortunately, to have to spend a lot of time kind of pulling your hair out trying to get the translation step working. So that's a really potted history of TensorFlow and my experience with ML on mobile. But I know a lot of what you've been doing in this class is actually looking at running stuff on embedded devices. And the story of how that came about also begins back in 2014 at Google when I first joined, because I was feeling pretty proud of the stuff we'd done to get TensorFlow, or to get models, this was pre-TensorFlow, to get ML models running on mobile devices, so phones and like the Raspberry Pi. And we'd managed to squeeze them down to like a megabyte in size. And so I was feeling pretty good about that. But then I met Raziel Alvarez, who at that time was leading the OK Google. And sorry if anybody else's phone went off. Mine just did. We actually end up saying OKG in meetings at Google to avoid that problem. But he was responsible for the wake word that runs on your phone all the time, listening out for if you've actually said the phrase to wake up your phone. And I was telling him about this 1 megabyte model size, and he very casually was like, oh yeah, we are able to run stuff, we have a model that runs in 30 kilobytes. And that kind of blew my mind, because I'd never imagined that machine learning, I thought we were really pushing the edge of what was possible and useful by getting things down to sort of single digit megabytes. But the idea that there was already this production use case shipping, doing something as important as speech recognition in just 30 kilobytes, really made me curious. So I didn't know anything about embedded systems at that point. I'd never worked with them. But as I dug into what Raziel and his team were doing, I realized that there were these 50-cent chips out there that could run on a coin battery for a year. And they only had a few hundred kilobytes. But if you could run such a useful application on one of them for doing this speech recognition, I was really curious about what other problems we could solve running on these devices. And as I learned about how many of them were out there, one of the interesting things over the last few years has been the sales of phones have actually kind of plateaued. And they've plateaued because you really only need one phone per person. And so the sales have plateaued because there are only so many people in the world, which is kind of a crazy thought. It still means that there are, billions of phones out there. But embedded systems can scale much. There can be a lot more embedded systems per person than there are phones per person. And we already see that with, tens of billions of, I think 40 billion or something per year was the last figure I saw for number of embedded chips that are sold every year. And that only seems to kind of keep growing. So I was itching to get back to working on this problem. So once we'd actually got TensorFlow, first TensorFlow and then TensorFlow Lite out there, and we'd actually achieved this success on the phone side, I had enough goodwill within Google to get a small team together, just a couple of us, for a year, and see if we called it TensorFlow Everywhere initially. It was this idea of, hey, let's see if we can get ML models running on these really cheap, tiny embedded devices. And after a year, we did the first release of TensorFlow Lite Micro, which you've been looking at and using. And we managed to squeeze the runtime down into 20 kilobytes, and set it up so that it would actually run on bare metal. A lot of the things that make it kind of a bit awkward to use, like the fact that you have to set up this arena of memory before you invoke invoke inference. That's specifically so that the framework itself doesn't have to rely on tools like malloc, which may not be present on some of the systems that it runs on. We managed to get, turned out the chip manufacturers like Qualcomm, ARM, Cadence, Synopsys, Siva, they actually were very keen to get ML models running on their systems. So they all contributed code once we open sourced this to actually optimize for their systems. It's been a great experience, because we've had this explosion of interest again in running stuff on embedded systems. But one thing that was a bit frustrating, and has been a bit frustrating, has been there's been a lot of research and kind of community interest in what we can do with these devices, but unlike the phone side, it wasn't we didn't see the uptake of people actually shipping products using this stuff outside of outside of a few big companies, places like Google that already had big ML teams. The reason I wanted to work on this stuff was because I had this idea that I want, these things that I wanted to see out in the world. Like I want to be able to look at a light switch and say on and have the light come on. Like it just feels like that should work. I want my TV to pause if I get up from the couch to go get a cup of tea. Like I shouldn't have to fumble for the remote. And it just felt like there were all of these, what seemed to me like obvious use cases for this technology, which were totally, doable. You've been doing things like, I'm sure, like the presence detection, running on an embedded device. That's exactly the sort of thing that you could use for like the TV use case. I would go to places like light switch manufacturers or TV manufacturers and say, hey, there's this open source framework with, there's free course material, there's like a book, we have this conference series, you could just grab it and build all these awesome things. And almost all the time, they would just kind of look at me at the end of my pitch and be like, well, we barely have any software engineers. We definitely do not have an ML team, and we aren't going to invest. We're not Google, who has a like geyser of money in the backyard from ads and can afford to do all of this like research stuff. We just don't have the resources for that. Can you just give us something that gives us a voice interface, or give us something that gives us that wakes up our TV when somebody sits down in front of it? And so, after hearing that enough, I decided to see if I could build something to solve that kind of problem. And so that's when I left Google back in January. You might have seen, we launched last month the first product from Useful Sensors, which is my startup. And this is a person sensor. See if I can get it closer. And this has a small camera on the front, and then a microcontroller on the back. And it comes preloaded with some ML software. But from the system integrator's point of view, all they need to know is that it's got one pin that goes high whenever there's a person around. And then it has an I2C interface that tells you where the people's faces are, and if they're looking at the camera, and also does some simple face recognition. And we've put this up on SparkFun and DigiKey for $10. And we're working with a bunch of consumer electronics companies to try and see if we can get this into some of their devices. We're actually working on a follow-up right now to recognize like hand gestures, so that you can do swiping, or for example, you can sit down in front of your TV and sort of pause it, do mute, maybe swipe left, swipe right. And we're really hoping that this makes it possible for people to, like these TV manufacturers, to integrate it without having to do a whole bunch of coding. They treat it just like any other temperature or pressure sensor. And the other thing that came out of my Google experience was, especially working on voice stuff, a lot of friends and relatives would ask me, hey, I was just talking about, Tunisia with my friend, and the next day I started getting all of these ads for holidays in Tunisia. Like, is Google spying on me? And I could say, because I knew the code, I could say hand on my heart, no. But I couldn't prove it. Like, there was no way that I could actually, point to any third party work saying that, no, this isn't happening, because it's very much this idea of you should trust Google. And for very good reasons, people are no longer prepared to just trust big tech companies at their word. We're sort of, there's been enough scandals and instances where there has been kind of things that were not well revealed ahead of time, that people are rightly want something more than just a company's word. And so a big part of what we're trying to do with this, and I'm actually going back to school myself to work on a PhD. I just finishing up my first quarter here at Stanford, to focus on this idea of smart homes without spying. So really trying to set up a system where you don't just have to take the manufacturer's word for the sort of privacy properties of a device. It's actually possible for like a third party, like, Underwriters Laboratory, or even I'd love Consumer Reports, to be able to analyze these devices and have some confidence that they can't be used for spying on customers, or at least can have a very clear set of information that they reveal. So, for example, the person sensor and the gesture sensor, which is using the same hardware, there's no access to the underlying camera from the rest of the system, so that even if the rest of the system gets hacked, people can't use this little camera on the front to spy on you, which is super important, because people often have TVs in their bedrooms, and you really do not want to be opening up any kind of vulnerabilities in sensitive areas of people's lives like that. And really the idea is that not only do we make this secure ourselves, but we make this simple enough that this system, this module itself, can be tested by third parties, and they can verify our claims. So then once it goes into a wider system, there's some level of confidence that this can't be hacked and used against people. And I'm hoping to do things like voice interfaces as well, using the same kind of approach. And yeah, I guess that's now brought you up to date on kind of my journey through this world. I would love to actually hear more from you, even if it's just to tell me about what projects that you're looking at working on, because I'm really interested in, there are so many different imaginative things that I've run across that people are doing with this technology. That's one of my favorite things, is just hearing about that. And I would also say as well, I'm happy to, I'll put my email in the chat, but it's just Pete Ward at stanford.edu. So PETEWARD. Feel free to email me with questions offline. I'm always happy to try and help people who are working on this stuff.
Hi, I had a question about the useful sensors. So is that like, do you have other sensors that you've developed, or any other cool or favorite ones that you could talk about?
Yeah, so the official roadmap we have is, we got the person sensor out. I'm hoping to get the gesture sensor out, it looks like maybe in January. And then I would like to get the full voice recognition out in the middle of 2023. But there are some other sensors that I would love to do. One of them is actually doing OCR, like optical character recognition, directly on just a little sensor. So for example, you could point the sensor at a water meter, and read off the digits as it's kind of counting up. And I've seen people using TensorFlow Lite Micro to do that out in the wild, which has been pretty cool to see, because it means you can take existing infrastructure and turn it into something connected without actually having to do any plumbing or do any sort of major changes. You just point this camera at the existing display, and it's almost like an analog to digital converter for the physical world. So I would love to have a little sensor that just reads whatever text or numbers are visible to it, and then just outputs that through a UART to the rest of the system. We've even had people who are working on appliances, like fridge manufacturers would like to be able to read the labels of things that people are putting into the fridge, so that they can actually have an idea of if people are running out of stuff, or if people want to hold something up to the fridge to add it to a list, add it to their shopping list. And it just feels like one of these things that could have a whole bunch of different applications. Another one that I'd love to do that we don't have on the roadmap is actually being able to do, like I said, the tapping on a solid surface and actually telling where people tap. If we were able to sell a sensor that you could just attach to any rigid surface and have it become like a touch screen, that would be really neat. I don't know how feasible that is, but I would love to see if we could support that. And yeah, I have there's probably some more, even things like recognizing, crop disease, crop pests in fields. I would love to be able to help support that and actually help out on the agriculture side, help people use fewer pesticides, for example. So yeah, I'm really hoping if we can actually get some customers for the initial versions of this, there are a whole bunch of other things that we could build. But I'm also hoping that other people kind of take the same idea of ML sensors and build their own solutions. I want there to be a thriving marketplace of kind of off-the-shelf ML capabilities that you can just buy. So if you have your own ideas, I'd love to help you get those packaged up in an ML sensor kind of form factor.
Hi, actually, I have an example project where the classes, we're currently all working on final projects, trying to find good use cases with TensorFlow. And this is my first ML class in general, so I'm still being surprised by every place it can be used. What I was working on, or what I'm still working on, is I'm a bioengineer, and my senior design project involves helping paramedics visualize veins in real time in the ambulance using pretty simple like camera processing tools. One thing I was curious about trying to use TensorFlow with is whether or not it would be feasible to do image segmentation in real time. Just to see, like, I don't know if you have any thoughts in mind of projects like that you've seen, but being able to identify, what pixels correspond to a vein versus surrounding tissue, and whether or not all that processing is possible on a, yeah, okay. Yeah, so the basic idea is to have like an armband with a camera of some kind, elevated from a forearm by like a few inches, and by using infrared like camera sensitive, you can see the vein on a screen, and you can get enough contrast there so where it's visible, and you can get a live video of the arm. But being able to use machine learning to identify what part of each frame is a vein and not has been a pretty complicated problem. I'm not sure if you have any other example projects in mind.
Yeah, no, that's and for that I would definitely start off with trying to do the processing on like a phone, or something that's kind of a bit more capable than just an embedded system, because hopefully in that case the paramedics will have something like a phone available. So maybe taking the feed from the camera itself and doing the processing on something that's a bit more beefy than you could have on a sort of a battery powered embedded system. The one thing I would ask, I guess, is, as a person, when you look at like the infrared images, is it obvious where the veins are? Or
much more obvious than without. Like
Yeah.
hemoglobin in the blood absorbs IR like 30 to 40 times more effectively than surrounding tissue. So getting the trace and doing some basic like contrast enhancing helps a lot. So machine learning wouldn't necessarily help the paramedics visualize. It would be used for some other functionalities, or just it being able to say, yes, you are the needle is above a vein, or it's not, when they're placing an IV or something like that.
Oh, I see. So just the IR view itself actually helps the paramedics, without having any machine learning involved. They actually get a much better view of the veins.
Correct.
It sounds like. I see. Yeah. And yeah, there's actually it's quite a popular thing to do, like the image segmentation side. One thing I would look at is things like portrait, or like cutting out people from cameras. That's actually something where you have to do segmentation, and there I believe there are a bunch of real-time examples of that out there, as open source code. And that would be a good example of, and most of them I think would be aimed at running on the phone, on phone class hardware. But, hopefully that should be good enough for your use case. And the idea would be that you would sort of adapt that, use different training data to actually adapt that to the vein use case. So let me know if you don't run across, if you have trouble finding examples. I'm happy to sort of, see if I can dig some out. So, drop me an email.
Oh, thank you very much. Appreciate it.
Yeah, because I have I have people in my family who are hard sticks. So being able to actually help, I've seen how painful it can be when you're struggling to actually find somebody's vein. So I think it would, what you're doing is a really high impact application. So I think that's great.
Hi, Pete. So I have a question about how you go about collecting data for your machine learning models. I'm trying to create a platform that allows crowdsourcing for machine learning data. So anyone in the world would be able to contribute to any data sets that get requested by researchers or companies. So do you think it has potential applications like in your sensors?
Yeah, I would like, one of the things we're doing with the Harvard group that I've collaborated with before, and Professor Reddy over at Harvard, is we're creating an open source reference implementation of the person sensor, and trying to make it so that there's an easy way for other people to kind of just put their own models on something with this form factor, and ship stuff out that way. I've always, for years, I've wanted to see a successful version of what you're describing. And one of the things that I've often thought about is it would be great to have almost like a visual version of Wikipedia. And I know there've been some attempts at this, but something where people could upload their own data, upload data sets or contribute to data sets, and then actually get a model out of the other side. And, I've thought about, there were groups like bird watchers who really care about being able to recognize different birds, and they have a lot of photos, and it feels like they would be happy to upload those photos to a big public data set with labels, and especially if in return they were actually able to download like a model for their phone that helped them do better automatic recognition. And so, yeah, I really like the idea of what you're doing. One extension to that is, I would start off with just, hey, can you auto train models on these data sets? But then once you've got that far, it might be useful to be able to, download models that you can just run on, a simple embedded device like this as well. And, even get to the point where you could just order the hardware with the models that you care about. And I've actually talked to Edge Impulse about doing something similar. And I recommend looking at their sort of interface for uploading data, because they do a really good job of it. But one of the things I would love to do long term is actually allow people to upload data to Edge Impulse, get a model they're happy with, and then they could just order a few hundred sensors with that model burned in. So that's kind of a long answer to your question, but
Thank you.
I hope that makes sense.
I had another question about like the sensors. So, is the microcontroller that you like put on these things, is it just like a normal like Arduino microcontroller, or do you? Oh, so is there any like is there any like interest in like using specialized like hardware that is like optimized to run these things to get them at lower power or something like that?
Oh, definitely. And really what I'm trying to do for this first round is just prove that there are customers out there for something like this, because you know it's kind of a new idea, this ML sensor approach. And but the nice thing is, once we have found some customers who are willing to buy kind of like the first version, which is using like off-the-shelf hardware entirely, we have the option to change out the hardware that's under the hood without changing the interface at all. So hopefully from a a purchaser's point of view, we could use a lower power microcontroller or a cheaper microcontroller, and none of their code or the rest of the system would have to change at all. So I'm hoping that this becomes a nice kind of sandbox for trying out new, specialized hardware and specialized approaches to all of this kind of stuff.
Yeah, that's really awesome, Pete. I think what we'll do is we'll put up like a dashboard with all these projects and share them with you. And we'll have our demo day on December 8th, and I'll let you know about that. And I think
I would love to call in if I get the chance.
yeah. I'll let you know now, because later today, so you'll have advance notice because it's already planned out. I think everybody's super excited about figuring out their projects now and then taking it forward. But I think then in the following semester, some of these are also doubled up as year-long senior design projects, so we can even follow through with them in the coming semester, in the spring semester, and take it to the next level. And so Pete has his own company, he's the big boss, so if you guys do well.
Yeah, no, I would love, I would love, we've only got a small team right now, but one of them is a student from last year's class at Stanford. So he graduated, and he actually did a really cool project about cerebral palsy, where he was detecting gait using an accelerometer and actually helping kids with cerebral palsy improve the way they walked. And anyway, yeah, he's awesome. He's now part of our company, and yeah, I'd love to see some of you come and check it out once you've graduated.
Yeah, so we can put together a resume book, but December 8th is a good time to impress me.
And feel free to use me as a resource too. I'm happy to help with with any of this stuff. I think what you're doing sounds really cool. So
yeah, so we can switch to the presentation now, if you don't mind. Then we have about an hour, and then I'll
let me bring that up.